Chapter 6 is a chapter about polygons, but the bulk of the chapter is going to be spent analyzing quadrilaterals, all the properties of different quadrilaterals. But before we do that, we're going to just begin with talking a little bit about some of the polygons that we mentioned earlier in the year. So let's just go through and name these polygons. We start off with the three-sided figure that we've been talking a lot about lately, and that is the triangle. Then we have the four-sided figures, which in general are called quadrilaterals. Quad meaning four. Five-sided figures are called pentagons. Six-side would be hexagon. Seven-side is heptagon. Eight-side is octagon. Nine-sided polygon is called a nonagon. 10-sided figure is a decagon. And let's add 12. 11 really doesn't get talked about much because it's an odd shape, but 12 sides would be a dodecagon. And maybe we should add up at the top, a polygon is a figure with many sides and many angles. No curves, everything must be closed. So many sides and many angles. A regular polygon is a polygon that has all congruent sides and all congruent angles. The fact that it's both the sides and the angles is important. Our smallest regular polygon is the equilateral triangle. So you can notch the sides if you want to draw some little figures for yourself on the bottom there. I don't know if I left you quite enough room. And notch all the angles. And all the angles, we've already talked about this, would be 60. The next one, the quadrilateral that's considered regular, is the square. And those angles are all 90 degrees. And once you get past the square, you have to put the word regular with the figure. So if it's a five-sided figure, it's a regular pentagon. 5 congruent sides and 5 congruent angles. And a six-sided figure would be considered a regular hexagon if all the sides are congruent and all the angles are congruent. And so on. Okay, then remember we talked about the fact that we have interior angles and exterior angles. So our interior Our interior angles are the angles that are on the inside at each vertex. So these are our interior angles. And at every vertex you can draw 2 exterior angles. We're just going to consider 1 at each vertex. And remember, you extend a side, and then it would be the angle that goes from the side out to that extended dotted line. So at each vertex, we can extend out and actually put 2. But we're only going to consider 1 for what we're going to do. And there are your interior and your exterior angles. To find the sum of the interior angles of any convex polygon, we have a formula. And the formula says that the sum of those interior angles is equal to n minus 2 times 180 degrees, where n is the number of sides. Now, first let's go back and remind ourselves what convex is. Convex is any polygon where the vertices are pointing outward. So these three examples would be convex. If I draw something that looks like this, so that there is actually a vertex that's pointing toward the interior, this would be called concave. The formula above only applies to convex polygons. And where the formula came from is the fact that we know that the angles of a triangle add up to 180. And if you took any polygon with more than 3 sides, you could divide it into triangles. So the square has 2 triangles. And 2 triangles is a 4-sided figure minus 2, which is equal to 2 triangles, times 180. Will give us 360. So in my pentagon, I could divide a pentagon into 3 triangles. Well, a pentagon has 5 sides, and 5 minus 2 times 180 will give me the sum of those interior angles. The 5 minus 2, which is 3, represents the fact that I can divide that shape, the pentagon, into 3 triangles. So if I'm looking for the sum of the interior angles of a 14-gon, since we don't have a name, if it's 14 sides, we simply call it a 14-gon. We're going to say the sum equals n minus 2 times 180, or 14 minus 2 times 180, which is equal to 12, times 180, or 2,160 degrees. So if my figure has 14 angles, those angles are going to add up to 2,160 degrees. If I said to you the sum of a polygon's interior angles is equal to 4,320 and asked you how many sides the shape had, then I would simply say my sum is equal to n minus 2 times 180. Now you can do this 2 ways. You can either divide both sides by 180, or you could distribute the 180. I'm going to choose to get rid of the 180, so I'm going to divide both sides by 180, and that's going to give me 24 equals n minus 2, and if I add the 2 over, I get 26. So my shape, my polygon, has 26 sides if the angles add up to 4,320 degrees. To find individual interior angles, if I'm talking about a regular convex polygon, so this only applies to regular polygons, the measure of each angle is given by the formula n minus 2 times 180, which would be the sum of all the angles. And then we just divide by the number of angles that we have. So we're dividing by n. N is the number of sides. It's also the number of angles. If you have a 4-sided figure, you also have 4 angles. And these formulas are important, and I will expect you to get these memorized. So what is the individual interior angle measure of a regular decagon? Well, I'm going to say a regular decagon has 10 sides. So each angle will be found by doing the sum of all the angles divided by the number of angles. or 10 minus 2 times 180 divided by 10. And that's going to give me 144 degrees. Each angle of a regular 10-sided figure will measure 144 degrees. Now, those exterior angles, which are the ones on the outside, if we took one at each vertex, those are going to add to 360. It doesn't matter how many sides there are. The exterior angles, one at each vertex, will sum to 360. So if I'm looking for the sum of the exterior angles of a convex, let's say it has 20 sides, there's no work to do, it's 360. If I'm looking for the sum of the exterior angles of a convex polygon that had 101 sides, it's still 360. To find the measure of each of those exterior angles, then, I would take the 360 degrees and divide by the number of angles, which is also the number of sides. So this is the individual exterior angle, or each exterior angle. So if I'm looking to find the individual measure of an exterior angle of a regular dodecagon, what I'm going to say is dodecagon is 12. That's a 12-sided regular polygon. So if they all add up to 360, and I divide by the fact that there are 12 of them, then each one must be 30 degrees. Okay, so at the bottom, you have a polygon, and they gave you 108, 121, and 59. They're asking to find the measure of that missing fourth angle. So the first thing you're going to say to yourself is, this is a four-sided figure. I know that these are going to add up to 360 degrees. If I take 360 degrees and I subtract the 108 plus the 121 plus the 59, it's going to leave me with my x, and that comes out to 72 degrees. The first thing you have to know is what the sum of the interior angles is equal to. And this is one that we didn't have to calculate. We all know that four-sided figures are going to add up to 360. Okay, in our last example, we have a shape that's giving us exterior angles of x, 2x, 89, and 67. And since we know that those are going to all add up to 360 degrees, there would be my equation that I would use to solve. And if I combine like terms, I have 3x plus 156 is equal to 360. Subtract the 156 from both sides, and I'll get 3x equals 204. Dividing by the 3, I have x is equal to 68. So this one is 68. Oops, and if I double my 68, that's going to give me
John Harkin, please call 100.
132. And you can check that by making sure that those all add up to 360. Okay, that is our Chapter 6, first section.